Hi, my name is Matt Demeglio and I am a tutor at the School of Computer Science at UNSW, and today we're going to look at how to use stacks to solve a simple problem. So the problem goes like this. We'd like to write a program which reads in a sequence of numbers from standard input and writes those numbers to standard output in reverse order. So in this course we've already seen one way that we could approach this problem. We could have an array and we could read those numbers into the array in increasing indices of the array. And then when we want to print them out to standard output, we just iterate through the array from the end to the start, i.e. in reverse order, and print them out. But what we'd like to do today is see how we could solve this problem using a stack. So first, let's have a look at the way the order that items go into a stack compares to the order that items come out of a stack. So here we have a stack and several items which we're going to put onto the stack. So let's put item 1 onto the stack, and then item 2 onto the stack, and then item 3 onto the stack. And let's pull the items off the stack. We'll pull item 3 off the stack, and then item 2 off the stack, and then item 1 off the stack. Notice that when we pulled the items off the stack, the order that they came off the stack was the reverse of the order that they went onto the stack. So we can use this property of stacks to achieve what we want with our program. So let's have a look at some code and how it works out in practice. So we've got some code and we're going to run our program called reverse, and we've typed in a sequence of numbers into standard input, and let's see what happens. So the numbers have appeared in standard input. Now we're going to create a stack. Okay, and we're now going to scan in the first number into the variable I, and because scanf read in a number, it returns 1, so we continue with our while loop, and we're going to push the variable I onto the stack. Okay, so we do this again. So we're going to read in another number from standard input. And again, because we successfully read in a number, scanf returns 1, which means that the condition is true. So we continue with our while loop, and we'll push the variable I onto the stack. So we're going to read in again another number into the variable I from standard input, this time the number 46. And because it was successful, scanf returns 1, and because the condition for the while loop is true, we continue with the while loop and push the number 46 onto the stack. But now standard input has no more characters, and so when we call scanf, it doesn't actually do anything to the variable I, and instead just returns 0 because it didn't successfully read in any numbers. And so the condition for the while loop is false, so we're finished with our while loop. Okay, so now we're going to print the numbers out. So because the stack isn't empty, okay, we're going to continue with our while loop. We're going to pop a number off the stack, and then we're going to print it out to standard output. And we do this again. So the stack's still not empty. So we're going to pop the next number off the stack, this time the number 3. And then we're going to print it out to standard output. And we're going to check the while loop condition again. So our stack's still not empty, so we continue with the while loop. We will pop off the final element of the stack, the number 19, and we will print it out to standard output. And now we do our check. The stack is now in fact empty, so this condition is false. So we're done. Or are we? Have a think about something that we might need to do before our program terminates. Yeah, that's right. We need to call stack free because the stack, essentially with an ADT, the data corresponding to that ADT has to be malloc somewhere in memory in order for these interface functions to return the object to us. So at some point in the future, obviously malloc memory has to be freed, and so there's an interface function to free the memory associated with that data type. So we need to call stack free. So now we're done. And our stack is freed, and our program's finished.